AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. My name is Guilherme Martinez Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar, A New Era for Retail with Intelligent Robots. This session is part of the AI for Good robotics programming track, exploring how AI-powered robots are helping to unlock our human potential and advance the United Nations Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. And without further ado, I would like to introduce our moderator today. His name is Michael Osborne, and he's Professor of Machine Learning at the University of Oxford. Michael, welcome, and the floor is yours.
Thanks very much, Guillaume, and welcome everybody to this webinar, one in which I'm very excited to introduce, and that I think AI and robotics, as we all recognize, has advanced very rapidly in recent times, in particular, even in recent weeks. And I'm very interested to see what our many distinguished panelists say about what the impacts might be on retail. So if you'll forgive me, I'll now move on to introduce our first speaker, who I'm very excited to say is Diana Baiku, who is not only one of the co-founders of Adapter Robotics, but also the lead robotics engineer and one of the minds behind MAT and Iris. And she is putting her skills towards developing and building robotic products that help develop technological advance, and not only creating meaningful products, but also spreading Adapter's values across industries and growing a resourceful and enthusiastic team. So Diana, thanks very much for joining us today, and very much looking forward to your talk.
Thank you very much, Michael, and hello, everyone. Allow me to continue with the presentation. Very well. So today we are discussing about retail and intelligent robots. And myself, I'm an engineer, so I'm extremely excited to talk about this today. But I think, first of all, it's important to have a base of what the retail scene looks like and how it has evolved over time, as well as what happened in the last few years. Well, about a little over 100 years ago, the most common model when it came to retail stores was what we call the counter service, meaning that there were some clerks that were taking in customers' shopping lists, and they were going inside the store to fulfill those lists. But towards the beginning of the century, there was a retail store, it's called Piggly Wiggly, in the US, that introduced the self-service model. And that was revolutionary because basically it shaped the way in which we view retail as it is today. It changed the store layouts because customers needed to be more focused on where the products are placed and also what their price is. So labels need to be introduced. But at the same time, it was a challenge for marketings because product labels needed to be better in order for a customer to choose a product. And when the pandemic hit, we could say that a similar change is about to happen, because in that point, even though online shopping has existed for more than 2 decades from the beginning of the century, we have seen only in 2020 an increase in 40% in the online shopping usage worldwide. And at that point, when we saw that increase, we might have thought, well, maybe this is the end of brick and mortar stores. And it was fair to assume that that would have been a paradigm shift. However, what we saw once things have started to come back to normal was that consumers and customers came back to brick and mortar stores, and statistically, their reasoning was that they wanted to disconnect from the digital, from screens, from computers, from being connected all day, and go ahead and explore new products. But at the same time, they were more focused on experiences, on what the store could provide in terms of engagement. And at the same time, they were a little bit more attentive to the errors and more aware of those errors and potential problems that could appear inside the store. Regarding this, there is a term that is extremely important for us to take into consideration, and that is omnichannel. Omnichannel means that retailers nowadays try to offer as many options as possible for their customers. Either we're talking about apps or websites, and all of those combined with the actual store, the physical store. And more than that, they want to combine those two. So not only provide an app, but also provide the possibility for you to go in the store with that app, and while you do your shopping, to be able to scan your products and at the end pay for them with what you have scanned. However, this is where the challenges start to come up. And just imagine this: you are scanning your products, and once you do a scan of a product that you put in your cart, you see that there's a difference in the price on the app versus what you see on the shelf. And you can think that this leads to confusion. This even can lead to a bit of mistrust in the retailer itself. They don't know what is the actual price after all out of this. So customers do have increasing expectations. Everything needs to be done perfectly across all these channels. And that puts a lot of pressure on operations. That right now, the way things are is that they are handled manually by employees in stores. So they can be aided by technology, either by apps or any type of scanning devices, but they need to go at the shelf and check manually all the prices, check manually that all the, let's say, products are available on the shelf. And if they're not, to go and check with the inventory what the availability is. And as you can imagine, this takes a lot of time. It's extremely tedious task. And we as humans are very prone to errors happening. We might see happening the same errors again, even though these operations are being done and the checks are being done. Well, luckily enough, this is where robots shine. It's a challenge, so robotics together with AI can help us in these endeavors. And let's take a look exactly at where the robots can be used in retail, because there are many, many applications. I have just a few here, and that can start from warehouses and logistics, for example, packing and unpacking orders and products, to checking the aisles for any type of spill or anything else that has happened there. So cleaning robots, as well as ensure security. But what I'll be more focused on, because this is my experience from the last couple of years at Adapta, is regarding what we call in-store operational robots. Now, let's see some of the tasks that these in-store operational robots can perform. The first task is regarding what I have presented until now, regarding the correctness of the prices displayed on the shelf. We can do this by using computer vision and vision systems to look for the prices and to look for any product that has a bar tag, a label displayed, and identify that product based on the barcode, for example, and then take out its price and see if that is the final one that will be paid by the customer. Of course, in this case, if an error is identified, it helps a lot to actually correct it on the spot. And I will show you shortly how we are doing this. At the same time, when we're talking about electronic labels, they also need to be corrected. So these also need to be provided for retailers. Moreover, inventory scanning, it's another task that we need to provide for the retailers. And why is that? Imagine you go to a store and see that your favorite product, for example, your favorite beverage is out of stock. Well, you will go to another store to buy it because you don't want to replace it. And that means lost business. And very likely the customer will go disappointed from that store. So inventory scanning is what in-store operational robots can do. They can take a look and see if products are missing, but more than that, they can estimate how many products are available on the shelf, what we call on-shelf availability. If that on-shelf availability is below a certain level, critical level, stock necessities can be issued so that employees can come and actually fill those in, so that we don't have dissatisfied customers at the end. Another task that robots can handle very well in retail is planogram compliance. What planogram means is basically we're having a map of a shelf. We have a picture of how it should show, how the product should be placed. And those maps depend a lot on the retailer, on what other contracts they have, or simply on their internal layouts. And all the products need to be placed a certain way. But of course, an employee or a customer even can take a product and swap it with another one. This is where these checks come in. We are scanning the shelf, and while we are scanning the shelf, we can create a panoramic view of it. So you see, as we go near the shelf, we are putting images together on how the shelf looks like. At the end, we have this full image of products on the shelf that we have scanned, and we can go and compare with the reference map to make sure that all the products are in the right spot. And there are many things that happen here, and I would like to go a little bit over what are the technical characteristics and how we can make this happen from a robotics point of view. Well, this is the product that we have, and we are using mostly a vision pillar. From our experience, it is powered by cameras, which produce an impressive quantity of over 56 gigabits of data per minute. We could not process this in a classical way. And what I want you to be aware here is that such systems would not be available 10 years ago, for example, because the technology would not allow, maybe even not 5 years ago. So we are in a very good spot right now when we can process all this data directly on the robot by using neural networks, so AI systems, and that can process images, visual data. We do send reports at the end to either management or responsible people, employees that need to correct and be aware of them, over an integrated connection that is done there. At the same time, it was very important for us to, and also for the well-being, to make sure that the well-being of the employees is ensured, and which is why we have this human-operated version. At each time during the scanning, the operator is guided. You need to go faster, you need to go slower, and you need to have this distance from the shelf. In our tests, we have seen an increase in performance with the robot scanning the shelves together with the human operator with more than 50 times. So it was 50 times faster to scan the shelf with the robot than doing it manually. So as you can imagine, that means that not only retailers will be less prone to errors, but at the same time, employees will change for being simple manual handlers to robot operators, which we can make a comparison to what we have discussed in the beginning regarding the transition from counter service to manual to self-service for clients, where the employees had to switch from clerks and shopping assistants to being cash register handlers, for example. It's the same here. The roles change and the jobs become better and better, but at the same time, the customers are better served because they are easier and simpler, faster to be served by those employees that have more time at hand. Thank you very much for your attention, and I will wait for your questions and discussions at the end of this session.
Huge thanks, Diana, not least for being spot on time. Much appreciated. And I certainly have loads of questions I'd love to ask you, but I, alongside with the audience, will hold those in abeyance till all have spoken, and we can discuss after all speakers have had their turn. So
Thank you.
Thank you, Diana. So next up, we have Cosmas, who is the Director of Data Insights in the Robotics Division of Shopify and one of the early pioneers since 1999 in the use of machine learning and AI to solve real-world problems in various industries, ranging from CRM to travel to water to biotech, and now he's working in logistics, so he's worked all over the place. He has a PhD in computer science and has 11 issued patents and a 25-year career spanning R&D and leadership positions. So we're delighted to have Cosmas to speak to us today. Please take it away. Thank you, Cosmas.
Thank you, Michael, for this introduction, and thank you for the opportunity to speak on AI for good. I'm honored to be on this panel. So in today's presentation, this is the outline. I will, after a short intro, I will talk about the evolution of robotics and AI. We'll spend a little bit of time talking about large language models, and then we'll talk about the applications in logistics and warehouses. And I'll finish with some thoughts about the future of AI. So in introduction, I started originally as a physicist and then switched to computer science, and I made a data science career. I have been working for more than 20 years applying data science in various domains. And I pioneered the application of AI and machine learning for real-world applications since '99. And now I'm working in logistics and working with AI and robotics. So the evolution of robotics. Robotics is defined as the physical automation with machines, and it has come a long way from single task machines to backflipping robots. I'm sure everybody has seen the Boston Dynamics videos. And at the core of this evolution is artificial intelligence, which provides the brain of these robots. So let's talk about computer intelligence and its evolution. So computer intelligence, you can say that it started with statistics, which is century-old discipline, and statistics can discover simple data relationships. But in the last 50 years or so, machine learning was created, and machine learning can learn complex data patterns and can build specific models. And then, based on machine learning, artificial intelligence is what integrates multiple models, and it can create general-purpose intelligence. Part of artificial intelligence is the large language models that recently you hear all about them. And they have billions and trillions of parameters. They're really large, and that led to some emergent abilities. And let's talk a little bit about LLMs, large language models. Essentially, these are neural networks. And neural networks is a simulation of how our brain works, but a simulation in a computer. And the concept of neural networks started in the 1950s, but then it progressed over time. And in the beginning, there were only 10 or 100 neurons. But right now, the models, the large language models and the neural networks can have 1 trillion neurons. And that led to the unexpected rise of some emergent abilities. You can see here on this diagram, for example, arithmetic or math. A neural network or a language model cannot do math up to a certain size. And if it goes in size to, let's say, 10 billion neurons, all of a sudden, it can do math. It understands math. Or all of a sudden, it can translate between languages. It can understand humor. It can write poetry, and so on. And this graph shows how these abilities jump after a certain size. And for a more visual representation of this idea, you can see here, we gave a prompt to a large neural network to create a photo of a kangaroo wearing an orange hoodie, blue sunglasses in front of Sydney Opera House and holding a sign that says, "Welcome, friends." So this is it with a fairly small machine learning model. You know, it's not that good, right? But then you increase the size, you double the size, and okay, it's better, right? This looks like a kangaroo. Okay, and then we increase the size even more on, oh, okay, that's pretty good now. And the building behind it looks like the Sydney Opera House. Now, the writing is not perfect yet, but then if you increase even more the size of the network, now this is perfect, exactly what the prompt asked to do. So this shows how with larger models, we get better results. So let's switch now to talk about logistics. AI and robotics in logistics can be used in many different applications. For example, self-driving trucks, and soon we will have autonomous ships and drones. You can do inventory audits, for example, with autonomous either robots or drones that fly around the warehouse. We can have goods inspection with AI and machine vision. We can check for physical safety and security. There are robots that roam around warehouses and check everything. Even in my neighborhood supermarket, there's a robot that goes around and checks the surroundings. AI can be used for demand forecasting, can be used for route planning, and many other applications in warehouses. So in warehouses specifically, the types of warehouse automation we can have is either goods to person, which basically carousels that bring items to the workers, or AMRs, which is autonomous mobile robots, or even humanoids the last couple of years. But I think the best application is collaborative robotics, because humans are great at certain tasks, robots are great at other tasks, and it's up to us to figure out how to combine the two, humans and robots together, to achieve the best results. And AI, of course, can control the robot fleet, and AI lives also within each robot and can be the brain of each robot. So talking more specifically about autonomous mobile robots, this is what my company is working on the robotic side. So you can see here an image of this autonomous cart, and basically you can play follow the leader, because the robot knows where to go inside the warehouse, and the associate, the worker, can just follow it, and then it stops at the areas where an item needs to be picked and presents the item on a video screen. This reduces dramatically training time. A new worker can come into a warehouse and within 15 minutes can be very productive. Also, it reduces accidents, because workers do not need to push around heavy loads in carts, but the robot is hauling the things around the warehouse. And so it increases worker productivity, and the workers, frankly, are happier and improve warehouse operations. So this is an example also, a graphic rather, that shows how humans, the human productivity, can be from very productive, high peak rates to much less. But when you combine humans and robots, everybody's becoming very productive immediately. And let's talk about the future now. So automation and intelligence. The artificial intelligence and machine learning will be everywhere. We will see virtual bots running on our computers, running on our cell phones, and even physical robots all around us, in warehouses, out on the streets, on supermarkets, even in our own houses. And particularly the LLMs, the large language models, they have created a revolution. And now we expect them to sit and trained even on small computers, laptops, and run on smartphones. And that provides us with incredible intelligence. In fact, lately, they have started creating generative agents, which basically can autonomously, you just give them a goal or a mission, and they can go autonomously and complete the goal. And we will see millions of AIs all around us. Now, what will be the societal impacts of that? Well, the nature of work changes. It's going to be less toil, and we will be able as humans to be more creative and even more managerial, because with AI, you have an assistant that you can guide, and they can accomplish a lot of the groundwork, so to speak. This will have a direct impact on knowledge workers. We've already seen that AI increases productivity 10x for knowledge workers, but indirect impact on everyone. This can lead to a rapidly increasing world GDP because people become more productive. It might even solve the energy problem. Google's AI, DeepMind, was able to control a nuclear fusion reactor. So that has the potential to give us unlimited energy. Now, countries need to adapt to that. Perhaps they will consider moving to UBI, Universal Basic Income, or even shorter work week. And I'm sure everybody would like that. And we will see huge advances in science and technology. And these are all the benefits. Of course, there are some risks. Perhaps the biggest risk is the spread of misinformation. So we are moving, unfortunately, to a post-truth world, and we need to adapt to that and figure out how to cope with this change. And we will also see the emergence of super AI or artificial general intelligence. And it's anybody's guess when this will happen. Some people believe it's going to happen in a few months. Some people believe in a few years or even decades. Well, I think it's going to happen sooner rather than later, but we can talk about it later. And that concludes my presentation. Thank you very much.
Brilliant. Thanks very much, Cosmas. Again, a fascinating presentation and one that was spot on time, so I really appreciate that. And again, if I could ask you to hold your questions until the end, that would be much appreciated. As we now introduce our next speaker, Myrna McGregor, the Principal Data Strategist and Lead for Responsible AI and Robotics at Ocado Technology. So Myrna is responsible for identifying how to use data and machine learning to keep Ocado at the cutting edge of e-commerce, supply chain logistics and robotics. And she also ensures that Ocado develops these technologies in a fair, transparent and trustworthy way. And Myrna's had an interesting career in that she led Responsible ML at the BBC, where she developed the first comprehensive standard for responsible ML in media. She's also a former British diplomat, having worked on international economic and climate negotiations and serving in Kosovo, Belgium, Germany, and Israel. So, Myrna, a real pleasure to have you here. Looking forward to your talk.
Thanks, Michael. So today, similar to Diana, I want to talk about some of the challenges that we face in the space of online grocery retail in particular. Some of the ways at Ocado we've used AI and robotics to solve some of those. And part of my portfolio is specifically thinking about responsible AI and robotics. So I'm really excited to share some of our work on that. So firstly, to introduce Ocado Technology. So I like to think of us as almost 5 businesses in one. So we bring together a range of capabilities, really an end-to-end, from e-commerce to logistics and supply chain, fulfillment, advanced robotics, and advanced technology. And weaving that all together for our retail partners around the world. So companies like Kroger in the US, Aeon in China, in Japan, so based in Canada. So a real range of partners. And then, as I mentioned, using capabilities in AI, Internet of Things, big data, robotics to help them solve some of the issues they're facing and move into profitability. So just to summarize some of the challenges specific to online grocery in particular. So you've got big differences in basket sizes from people wanting a few items, perhaps to top up their evening recipe, to a family wanting to do a week's worth of shopping. You've got different lead times, as I mentioned. So you want that immediacy. I need something quickly, need something now. I don't have time to pop out. or I'm planning way in advance for a party, or even for Christmas. So we get Christmas bookings weeks, if not months in advance. People want to update their orders as their needs change, and so they want to frequently update that as well. Additionally, you've got 3 different temperature regimes: ambient, chill, and freezer, short shelf lives of particular food items, and topping off that, also a very high cost to serve and very low margins. And so we feel that automation and AI and robotics can really help us squeeze profit out those margins and maximize efficiency and get people the biggest offer at the lowest price. So I'm going to chat you through some of the capabilities that we have. So I'll start with kind of non-robotics ones. So personalization in e-commerce. So we've developed a feature to try and make your weekly shop as easy as possible, given a lot of people's shops are quite routine, tend to order a lot of the same items. And so we've developed a feature using AI whereby there's a smart shop where 1 click and it will fill up your basket with a mixture of the right things that you've tended to buy in the past, given your order history. Using AI to predict demand so that we're ordering the right thing at the right time, and so we're not left with a surplus of stock that's difficult to get rid of, particularly given those short expiry dates. So using deep learning to automate stock replenishment decisions. For our partners are finding able to use that for over 98% of their decisions, and really maximizing availability while driving down purge. So we've got an industry standard low purge rate of only 0.4%. So obviously good for businesses, but also good for the environment in reducing the amount of food that's thrown away. Onto robotics then. Our key robotic application is what we call the Hive. It's a mixture of a grid and thousands of bots that whiz around the grid, finding items that need to be picked for particular orders. So in the past, where it would have taken someone in a supermarket going around shelves, perhaps an hour and a half to pick a 50-item order, the bots can collaborate and pick that in just 5 minutes, and also pick orders simultaneously. And we use machine learning to analyze all of the data that this Hive generates, and also to monitor the health of the grid overall. Something that we've introduced recently is robotics for automated frame loads. So frame load is loading outbound totes from conveyors onto frames ready to go into delivery vans. And it's one of the most physically demanding and difficult jobs in the warehouse, given the weight of these totes. So it's a good application for a really difficult job to use a robotic system. And one of the reasons why AI helps here is because even though a tote will have a standard size, they live really hard lives in the online grocery chain. And so each will have slight imperfections. So you need to use real-time computer vision to notice these slight imperfections and adjust for them in real time. Another application we're developing is on-grid robotic pick. And so if you think about the scale of the challenge for this, we've got something like 50,000 or more products that a robotic system needs to be able to recognize, pick and pack. And they're all going to be different shapes, sizes, weights, fragility, non-technical term, but I like to say squishiness, ability. You can't put certain things together because they might, if one leaks, they'll spoil. And then they need to be packed as densely as possible for efficiency in order to be loaded and delivered. So combining machine vision, reinforcement learning, and advanced sensing make sure that these picking arms are able to pick without prior knowledge of what's going to come up in a particular order, and then make those decisions on the fly. And the final thing, it's a bit more speculative, but really exciting if we can make it work, is thinking about autonomous delivery and whether people are willing to receive their groceries in this way. But we are partnering with Wave and Oxbotica to do some testing and trials of on-road autonomous driving, and thinking also about what that customer proposition looks like in terms of how you would receive your order in this way. And the exciting thing about that is not only the autonomous element, but also these are EVs that we would be using. And so they're a much greener, more efficient solution if we can make it work. So finally, I said I'd talk about specifically the responsibility element, which is very much in line with this grouping, talking about AI for good. So I wanted to chat you through, I guess, the business case for why you need that responsibility lens when you're thinking about AI, including robotic AI. So I think AI systems in particular need additional special attention because of the way that they operate. They're not traditional software in that they can be opaque, they can be dynamic, they may change according to different inputs. And you've not got that A plus B equals C trackability of outputs. And so you need additional scrutiny when designing and deploying these kinds of systems that operate at the scale that they do. I also fundamentally believe that taking care to build well, and in the sense of well, reflecting some very well-established principles in the responsible AI space around fairness, security, robustness, and transparency, is not a nice to have. It's fundamental to whether this system works. And so by building well, you're also building in the right way, hopefully building once and not having to go back to the drawing board if you're getting unexpected or problematic outcomes. The third reason is I think that doing this responsible design and thinking particularly around transparency, explainability, or explicability is really key to getting the trust of those that are going to be working with, interacting with, or subject to some of these systems. And so if it can be explained even at model level, rather not always in an output level, how these systems have been designed, what they've been asked to take into account, what guardrails have been introduced in the design phase, they're much more likely to trust the output of those and either cooperate with or adopt the system that you're designing. And the final reason is AI regulation is coming, particularly the EU AI Act, but also in other jurisdictions. And so by doing some of this work before these come into force, you're going to be able to get ahead of that and make sure you're in a good position in terms of compliance. So moving into the work we're doing at Ocado. So we've just announced a set of high-level commitments, which are going to guide our approach to both designing and deploying AI, including robotic AI. And these are around fairness, so addressing unfair outcomes, representative data, high quality data feeding into these systems, transparency and explicability, ensuring that we have those explanations at an appropriate level of detail in clear language that people can understand, and also good documentation of our technical documentation, but also project documentation that we can scrutinize if necessary. That feeds into governance as well, a registry of the projects that we're developing, and that also includes projects that we are buying in from third-party companies or tools. Robustness and safety, so monitoring for performance, thinking about physical safety in a robotic AI context, and also explicitly thinking about the impact of deploying these systems. So just a quick slide of what that means in practice.
Manna, if you wouldn't mind wrapping up quickly.
Yeah, 1 minute?
Yeah, thanks.
Great. So in practice, we are delegating the implementation of this to teams because they're best placed to think about what's most relevant in terms of each of those commitments. We are using them as a guide to scrutinize third-party AI. And also some key things is we're trying to drive a bit of cultural change and increase our maturity in thinking about responsibility by introducing inflection points, formalizing a registry, and also extending skills programs. So that's where we're at. Really happy to take questions a bit later. And I'm sorry for overrunning slightly.
Thanks a lot, Manna. And again, a fascinating talk, one that really resonated with me. So thank you very much for that. Again, please hold your questions until after all speakers have spoken. And our next and final speaker is Ariel, who is the co-founder of Zipedi, which was founded with a vision of revolutionizing the way that the retail industry operates through AI, and has now deployed hundreds of robots across some of the largest US, Latin American, Australian, and European retailers. But Ariel has had a storied career, previously being the Senior Vice President of Customer Solutions and co-founder of Scopix. He was part of the team that started Matrix Consulting, a boutique management consulting firm in Chile. And he began his career developing mathematical models used by large forest companies to run their operations, and has also worked as a consultant at Bain & Co., has served on the faculty of industrial engineering at the Universidad de Chile, and has been teaching executive MBA classes at the Universidad Adolfo Ibáñez Business School, which I've probably mispronounced. I apologize. But anyway, Ariel, thanks very much for joining us today, and I'm very much looking forward to your presentation. Thank you.
Thank you very much. Okay, can you see the presentation?
Yes, thank you.
Okay, perfect. All right, thank you. So, thank you very much for the invitation. So, probably a lot of the things that I have here, some of you, the other speakers have already talked about, So basically, I want to give a little bit about what we do at Zipedi and how this is actually happening in the real world. So one second. Okay. So as Diana mentioned, we had the first supermarket, self-service supermarket, was this Piggly Wiggly in 1916, and actually since then, if you go to a supermarket today, there isn't too much change that has happened in the supermarket industry, probably other than, not in the supermarket industry, inside the store, probably other than the barcode, when the barcode was invented. There are a lot of things that happened in the inventory side, so all warehousing and how that all the advances that have been made in warehouses, and also once the POS data was available in understanding what customers do. But what's actually happening inside the stores is something that is very, very little understood, and it's something that's there's very little transparency. And you have now big retail chains that have thousands of stores, and each of those supermarkets have on average 30 to 40,000 items. Basically, just like in the home improvement industry, for example, there are over 500, and grocery over 500 billion products that need to be moved every year. So it's a huge amount of physical products that are moved without really any structure information of what's happening. So, and then I think that happened until a few years ago, when the advances in AI allowed these robotic solutions. Basically, the problem of that has happened in practice is that with this lack of information, there are things that for people that are not in retail seem like shouldn't be such a problem. For example, the big one is the out of stocks, and why the out of stock happens. One could think that this could be something very easy. It's like products come in, so we know how many products came in. Products go out at the cash register, so we know how many go out. So how much inventory do we have for each product? It's basically we need to do some basically some arithmetic, and we know how much it is. But the problem in reality is that you have customers that go in and then move products around. Somebody breaks a product, somebody steals something, and again, and you're having 30,000-40,000 products inside the stores, and things start to degrade. So the inventory starts to degrade, and all these systems about automatic inventory systems, and the problem with them is that they don't rely on good data, and then you have problems where you have a lot of out of stocks. Industry levels talk about 10% of out of stock. The other problems is missing assortment, promotions, compliance. You're never sure if people took away the compliance, the POP material, planogram compliance, the pricing issue that Diana also mentioned. It's also a big thing. And labor cost, it's very high, and there it's a very actually routine and not very satisfying job, just fixing these things and trying to understand what's happening. And with the market labors that we have seen, it's becoming more and more difficult. So overall, this in the industry, just in the US, we're talking about over $1 trillion that are lost because of this issue. So it's a huge opportunity of improving productivity. So the solution that it's basically these robots that the way we have implemented these are autonomous robots that go around the stores. We have today over 200 robots in the US, in Latin America, in Australia, and now also a few in Europe. And they basically go around collecting, basically going with the cameras and collecting the data of what's happening in the store. And what we call this actually a digital twin. So it's not only what's happening with the products, but you can also get like a 3D vision of the whole store. And the tip of the iceberg of the solution is it's what they call the inventory robots, the inventory, but in general, in reality, there's much more than just the inventory. Just in terms of the amount of data that we are actually, so you can imagine, these robots they're basically traveling about 300,000 kilometers per year. We have over 3 billion labels that are every year that are scanned, and it's something that's happened within the robot and some other parts are also in the cloud because of the deep learning models. They need to they need very high processors. Basically, the solution then it's this the robot capturing the data. We create this digital twin, and then basically through apps and APIs, we can we deliver this data to the retailers, to the store associates, to managers, to the different parts of the chain. The different products here. The first one is what we call the shelf execution, which has to do with, is the price correct? Are the products in the right location? Is there actually product in the shelf? Are the holes in the shelf? And that's the first one. There's once you have that data, you can start working on making the stores much more productive. Other applications that we have been looking into is e-commerce. So when people get you shop online to do online deliveries or in-store pickup. Basically, the products that the apps can show you, sometimes there's a lot of out of stock, and if the order is not complete, the probability of the customers actually not buying increases tremendously. So these are very it's a very valuable solution to know what's actually in the stores. Last mile delivery, this information is not only very valuable for the retailer, but it's also very valuable for the CPGs, the consumer packaged goods, the Unilevers, the Coca-Colas, so they can actually plan all their supply chain much better. Product location, it's also an interesting application for the final consumer that goes into the physical stores. We think this, so that's something that we have been working also. Cashierless stores, we have seen the Amazon Go stores, but usually they're very small stores. Having this data at this volume allows for cheaper or more feasible solutions for larger stores, cashierless stores. We think, even though now the metaverse and VR seems to be nobody's talking about that much after ChatGPT, we still think there's a big also opportunity there, and also for customers and also for people in the headquarters to visit the stores and know what's happening without actually going to the stores, which is actually that happened during the pandemic. Was a very interesting application. And of course, GPT, the big generative transformer models, not only language model, but all this data creates a lot of additional data that can feed these models, and I think will allow to interact for customers and management to interact with the data in ways that we can that are going to be very revolutionary.
Ariel, 1 minute left, please.
Okay, perfect. Yeah, so yeah, I think that's it. So basically, we believe that at the end of the day, there's going to be at least one robot in every store, and as we saw with the other panelists, and they're not going to be only. This is the digital twin, but once you have that information, you can start doing pick up, put a lot of other robots that can work in this previously unstructured data environment. So we believe we will see robots in stores growing and growing in the next years very quickly. So that's it. Thank you very much.
Fantastic. Thank you, Ariel. And thanks again to all the speakers for what I thought were a fascinating sequence of talks. Right. So now I think it's time for our discussion, which is, of course, the most interesting part of the session. And I might take the privilege of being moderator to pose at least the first question, which is one that I expect many of the audience will be wondering about. And a topic that some of you have already addressed explicitly in your talks, it's the topic of jobs. So, of course, we're talking about robots, we're talking about automation. And the prospect is, of course, of these tools taking away employment opportunities from humans. And I'd like to ask each of the speakers, in the order in which they spoke, to comment briefly on what their perspective is on this issue. Will there be negative impacts, positive impacts? What should we, if anything, do about it? So, Diana, would you mind going first?
Of course. We at Adapta, we have thought about this problem, which is why our solution does not have in plan to replace humans. We strongly believe that humans have a lot to win from collaborating with robots. And it has also been mentioned by one of the other panelists that productivity increases when this interaction happens, when a human learns how to operate or how to lead a robot into doing a certain task. Our model was to not start with autonomy and first make sure that the employees can actually make better use of their time after all, because instead of spending endless hours by manually checking the shelves, they can have a tool in which they can finish in 5 minutes what they did in maybe an hour and a half, or even more. So we strongly believe that there's room for creating not only better jobs, but more opportunities and learning experiences from the advancement that happens with robotics.
Thanks, Diana. So you seem to be fairly optimistic. Thank you. And Cosmas, what was your perspective?
Yes, I'm also optimistic, and we can separate this into the impact of robotics, and the impact of AI. The impact of robotics is what we have been developing, and what we've seen is that the collaboration between humans and robots improves safety, improves accuracy, improves productivity. And frankly, what we hear from the employees in warehouses that we deploy our solution is that they are happier. They avoid safety issues because they don't need to pull very heavy loads, and they know exactly where to go. They don't need to memorize, let's say, the warehouse. Robots can take care of all that. On the AI side, artificial intelligence, we've seen incredible increases in productivity for knowledge workers for now, you can use AI almost as an intelligent assistant, and you can be much more productive. Now, long term, we might find out that we will need to change the nature of our jobs, maybe become more managerial, each one of us, because you can give certain tasks to the AI, but then you can guide it. But we will see some change, of course, in working in the kind of jobs that people do, but I think it's going to be for the better.
Thank you, Cosmos. Again, a very optimistic take, I would say. Miana, what do you think?
Maybe I'll add a realistic take. So when we were pulling together our responsible AI and robotics commitments, it was a big topic amongst the group of people that helped me come up with those. And there was a real strong feeling that we needed to say something about the impact of automation, particularly robotic automation. And so that's why we designed a commitment for the company around impact. And we're realistic in that we know that some tasks are going to be automated. For example, the on-grid robotic pick I mentioned. And what we thought we should be asking our company to do was to be upfront about what was happening, communicate that in as much in advance as possible, but also think about the downstream impacts of some of those decisions to automate on the kind of work that we were going to be asked people interacting within the picking system to do, for example. If it's going to free up time, have a conversation about what that time could be used for. If it's going to change the nature of that job, again, to be upfront about that. So I think there's a responsibility that companies have to be transparent about what plans are, and then also to come up with a reskilling offer if that's appropriate. So we have one called Recode, which is about learning engineering skills. I met someone in one of our warehouses that had done every single warehouse job and was now had now become a robotic safety supervisor, which I thought was awesome. And his daily job, I think, seems to be colliding two robots with each other to see how they fare. So that also sounds like quite a fun job. So I think, yeah, it's about being transparent and upfront and offering alternative, I guess, retraining programs where that's possible as well.
Thank you, Myrna. That was fascinating. And finally, Ariel, what do you think about this issue of jobs?
So what we have seen is that a lot of this data, of course, it replaces it does labor that previously human should have done, but what we have seen is that a lot of times they don't have the time. So if it takes them 1 hour and a half to go over one aisle, nobody was doing that job. So when the robot is actually doing that, it provides now task and visibility of problems that arise. So holes need to be filled, planograms need to be arranged, and at the end of the day, and what we have seen is that when they do that, basically availability increases 10%, sales go up 2 to 3%. So, and that requires actually people. So in our actual experience, in general, retailers have been hiring people to do the jobs that basically the robot discovers jobs and tasks that need to be actually managed, and they need more people to do that, to do those jobs, and also then help. Also, it leaves more budget for the companies to help customers, which today is still a very human activity. So I think it's going to replace the tasks that the humans do, but it shouldn't reduce the number of jobs, at least in the short term. I think in the medium term, long term, what we're seeing with the large language models, it's going to be probably there's going to be things that might not be needed, a lot of jobs that might not be needed, and I think all their increased productivity, increased wealth that it will be created. We'll have to see how that can be use to really help everybody grow and improve their lives.
No, thank you, Ariel, and that makes a lot of sense to me. I wonder if I could try and pick apart some of the points made in each of your perspectives there and see if we can take them separately. So firstly, I think one of the issues that will be of most interest to much of our audience is the pace of change, which also has direct relevance to the economic impacts, right? I mean, it's a different thing if these technologies replace 1 million jobs in a year as opposed to replacing 10 million jobs in a year. I don't know, that clearly with how society can adapt depends a lot on how quickly these technologies both advance and are adopted across the industry. So again, if we go in order of the presenters, I wondered if you'd like to comment on just how quickly you see these technologies being adopted and having real world impact in retail across the world. So Dana, would you mind going first?
Sure. Well, here there's a distinction where there are two distinct topics. First of all is the innovation and the technological advancement, which happens at a rapid pace. Most of the time, if we're talking about technologies for consumers, this adoption can be extremely quick, depending on the domain. But when we are referring to technologies for businesses and industries, which is the retail, the topic of our discussion today, the adoption phase can be a little bit slower. As Ariel also mentioned, this retail industry has been exactly more or less the same for 100 years. So there is a lot of inertia around the processes and the way things are done. Things are changing, and the pandemic has been a major factor in the speed of change, but we will still see some years from now on some shy trials to start implementing more and more solutions, more and more AI, more and more robots within these operations, within these complex processes. But it will take some time to create trust and to make sure that they fulfill exactly the requirements of each retailer, which is, after all, our task as makers to make sure that those activities are handled good for them, but as well for the final beneficiaries, which are the clients of the retail chains.
Thanks, Diana. And Cosmos?
Yes. So again, this is a question that we have to separate between robotics and artificial intelligence and AI. In robotics, the changes would happen much slower because it takes time to physically design and build robots and then deploy them. What we've seen in the warehouses is that a small fraction of warehouses are automated even today, and they use robots. So it's going to take several years for that to be automated. On the other hand, with AI, the changes happen, frankly, almost overnight. Every week, we see a different level of AI being deployed and being immediately useful and available to the world. So I think AI will cause bigger problems, so to speak, because it also affects knowledge workers, many of whom have to spend a lot of years in training. For example, someone to be a lawyer, they need to go to law school. It takes many, many years. And if AI comes and can impact their work, because AI now can review contracts, for example, right? That has a much bigger impact to them than to a lower skilled job in a warehouse, let's say, that doesn't require a lot of training. So we have to separate these two. Now, how to address this? It's hard to tell. We will see. Things change every day with AI. With robotics, I think we'll have plenty of time to adapt. With AI, we have to be all more nimble, and one of the stronger skills that we can develop is to be more adaptable moving forward.
Thank you, Cosmos. And Myrna?
So from my perspective, not every problem requires AI. And I think the most responsible thing to do is to ask that question first and foremost, like, is this a problem that needs AI? And the second thing is, even for those problems or use cases which would benefit from AI or robotics or automation, they're not always AI ready. And so I think the speed of adoption and progress is kind of is a two-speed one. There's the really exciting technological breakthroughs and the headline grabbing applications and UIs. And then there's the day-to-day drudgery of getting your data in the right place, or even gathering data in the first place, making sure that it's accurate, making sure it's representative, building those pipelines, so that you can even apply AI in the first place. And so I think a lot of businesses and organizations find themselves wanting to leverage these technologies, but have a fair amount of work to do in the next months, years, in order to get their data and their processes in the right place as well. So I think that's a key limiting factor.
Again, thank you, Mona. That was great. And finally, Ariel?
Yes, so yeah, no, I think that there might be certain applications. I think this, for example, the inventory robots, we're seeing that it might go faster, but it basically touches probably a very small amount of labor. And it's also going to be, maybe it's going to start with like large retailers, large surface retailers, and it's going to be probably much slower to get into like smaller formats. So I think it's going to be a transition that it's going to take some time. But I think also retailers, I think they will have a challenge of really having very good experiences for customers. Again, if knowledge poor workers will have AIs to do much of their work, they have more free time. I guess they want to go and have good experiences when they go to the. So I think there's going to be probably a big need for experiences, entertainment, and I think retail probably will have to play a part of that world. And and also the other thing, I think it affects a lot of knowledge workers. I agree with Cosmos, and but manual labors, it's going to take much longer for robots to actually do that job.
Well, thanks very much all for responding to that. So my takeaway was that particularly when it comes to robotics and tasks requiring manual dexterity, the pace of change is far from that we're seeing in purely digital applications, such as being impacted by large language models. And there are also issues relating to adoption that are independent of technical progress. So that was very interesting for me. Thanks very much all. I'd like now to turn to some questions from the audience. So I have a question here from Jacob Willem Bruin, who asks, aside from reducing waste, in which ways do these solutions affect the SDGs, the Sustainable Development Goals? And at this point, I would just ask whoever would like to answer to go ahead and do so.
I can start. So some of the Sustainable Development Goals is one of them is zero hunger, for example. And this is where AI can have a huge impact with precision agriculture that uses sensors, drones, and machine learning to optimize crop yields and reduce water usage. Another goal is in clean energy, affordable and clean energy. And again, here is a place where we might see a revolution. Like I mentioned in my talk, Deep Fusion, the big machine learning model from Google, was able to control a nuclear fusion reactor. Now, if that can be productized within a few years, we will have unlimited, almost free energy, which is tremendous for the world. And also, this goes also for the climate action. If we reduce our dependence on fossil fuels through these advances, then this will impact very positively climate. So these are some of the benefits.
I would also add to this list that the work environments are changing. So the goal regarding the decent work and economic growth, it's also met through the advancements that we're talking today through robotics and AI, because as it has been discussed until now, the nature of jobs changes as it has changed all over throughout the time, and we're more inclined to use our creative abilities and our managerial, let's say, skills as well. So this will also be part of the goals that are changed by technology overall.
And I think also in terms of health and well-being, there's some exciting stuff happening around personalization of nutrition. And like I work in the online grocery space, and so we're quite excited about, I guess, personalizing on the basis of dietary preferences or requirements. There are other companies even personalizing supplements, vitamins, recipe boxes, and really prompting more healthy and personalized outcomes that way as well.
Thanks very much, all. We have another question. C. Nasir asked Myrna in particular if she could share more about Ocado's responsible AI and tech commitments. So please answer as you see fit.
Sure. I can say a little bit about how we came up with them and how we plan on implementing them. So I feel very passionately that responsible AI needs to be an interdisciplinary conversation. And so it was really important that I tried to pull together people from across my organization in order to come up with commitments that both drew from best practice in the industry, but also felt relevant to our business and the way we do business. And so there's that translation effort and also that representative effort. So if you're asking from the perspective of how do I do this in my company, I would say sort of pull a community together of people that feel passionately about this and want to contribute towards it. And then I guess you can build collectively while also drawing from some of the great frameworks that the UN and other organizations have put forward. The second one is about implementation. So the first step is to come up with some kind of guiding framework and principles. We've decided on commitments, and the much bigger effort is to thinking about how to implement those and action them in practice. So it helps to have resource backing them, like my role, but really it hinges on the teams either developing or procuring AI, robotic AI systems themselves, who know those systems best, know the risks and the opportunities best. And so it's about providing them with the tools, the questions, the working methodologies of interrogating those in a way that they see fit, and really bringing it as close to the problem and the use case as possible, rather than imposing too much as a organization-wide policy. Because one of the challenges of coming up with the approach to responsible AI is that it is a general purpose technology. So while you have questions that are commonly asked across different purposes, each one will have its own requirements. And so you need to think about individually. So that's why it helps to kind of push it to teams to think about, but also making sure that they are reporting back, recording information centrally, so that if, for example, there is an issue that you need to scrutinize or regulation comes into force where you do need to keep a registry or kind of transparency documentation, you've got some kind of mechanism for gathering and like recording that work as well. It's not a kind of one-shot thing. It's a way of working. And my last bit of advice would be to integrate it into how organizations already work. So kind of don't create additional friction if you can avoid it. A lot of this good work is already going on, so it's about formalizing and extending that as well. Thanks,
that was fascinating. We have another audience question from Nicholas Haftermia, who asks Ariel if you have any cost idea for Zippity. So I think the question is getting at, how do you help workers work with the robot, adopt the robot, and not fear it replacing their jobs? How can you help the workers adapt?
No, I think here, I mean, usually the way this starts, you start with one store in a new retailer, one store, then you go to 30, then you go to more. So there's a time for them to see how it works. But again, in general, these are tasks like looking for holes in the shelf. It's a task that nobody really likes to do. Another example, we're large home improvement stores. If you know, sometimes a lot of times they store the things on top, 2 to 6 meters above the shelves. They store the boxes. So there's a hole, and they need to start looking for where the product is, and they don't know where that product is. It's a very they call it the neck-breaking saver. They called it in one of this the robot, because it gives it the information, so they can look at it in the screen. They see the picture, they go, and now they can take it. The customer comes in and wants a product, and if the product is not there, the system says it is. They start looking in the store. It's a very frustrating jobs. So the robot is really helping them with information that they didn't have, so they feel much more empowered. And so we really haven't. At the beginning, we were scared about okay, what will people do? And we put the robot in a cage. But when you go to stores, associates really like it, because they see him as a coworker. They name him, they put him. It's like a pet for a little bit for the stores. They make sure that it gets through. So it's. But again, it depends on like how actually the company at the end of the day uses the information. But as far as we have seen, it's like always it's information that helps them do their job better, and they see this as a collaborative robot, which I think it's a word that has everybody has talked about here.
That's great, thank you. And we've been given permission to go beyond 1:15, and we still have questions coming in. So if all panelists are okay with it, perhaps we can continue on. So some of the speakers have already touched on the clear distinction between progress made in robotics and the progress that's been made in large language models in particular, which I'm sure everyone agrees has been breathtaking in recent months. So we have another question from Jacob Bruin, who's asking about how these LLMs will actually impact on retail. So in particular, what might the employment impacts be of large language models, which have achieved this breathtaking progress and rapid adoption worldwide?
Yeah, I would love to answer this question. So large language models, aside from being very smart, and in the latest tests, we've seen that they reached about 90% of human intelligence capability. But aside from that, they have another huge benefit, which we don't often talk about. The huge benefit is the following. They can simultaneously engage with 10 million, 100 million users and have 100 million discussions simultaneously. So that's a huge benefit, even at 90% of human intelligence, which, by the way, will keep increasing. We see this increasing very rapidly. So there is two ways that they can interact with robots. One way is that they can control AI, or large language models can control a huge robotic fleet and can tell each robot individually what to do, give it guidance, and so on. But second is that lately there has been a lot of work trying to decrease try to being able to run them on smaller infrastructure. And right now you can run a large language model on a laptop. And soon we will be able to run it on a smartphone. So that means that, yes, absolutely, they can run inside every robot. So every robot can have an LLM as its brain, which means that it will be at least 90% intelligent, as a human would be. And imagine the possibilities there. They can interact to new situations in, let's say, in a warehouse or in a retail situation. And as long as they have a good AI ethics score, and we really need to work on that as a society, that could be very powerful and very beneficial to the world. But we have to be very careful in that.
Yeah, I just want to add, I think I completely agree. I think this vision that they can manage a large fleet, it's very, very, interesting. It changes a lot of how you can work. I think the careful, it's not just only probably the ethics, just to complement that. I think it's also the error, because if in a conversation, the AI make a mistake, okay, you can, you can see, okay, it's different when you have like a robot physically interacting with a customer or driving a car. It's very, you cannot have errors. That an error can be very costly. So I think that's something probably that needs to probably improve, but again, at the pace that these models are advancing, it's going to be just a thing of time when they will be probably managing the robots as well.
Well, I think it might be just about time for us to switch over to the neural network. Is that right, Julian?
That's correct.
Well, right. Well, in that case, I'd like to thank all our speakers again, because I think we've had a really rich discussion over the space of the 4 talks, and in the panel discussion, we've brought out a lot of the most fascinating issues at the core of AI and robotics in retail. And thanks to all for bringing your unique and domain-informed perspectives on this fascinating topic. Really appreciated.
So thanks a lot. Thanks all speakers for participating today, and a big thanks to our moderator and all participants for making it such an interesting discussion. And we had lots of great questions and great insights on applications of retail robotics. And now we encourage you to check our AI for Good program online to see more robotic sessions that may be of interest to you, and especially to sign up for our upcoming AI for Good Global Summit 2023 that will be held in Geneva 6-7 July this year. So now this is the end of this section and the start of the networking in the AI for Good neural network with the panelists and participants for the next 10 minutes. So see you all in a couple of minutes. And now I will give back the floor to Anna for the closing information. Thanks, everyone.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.